Okay, so some great insights there into both internal and external sources of data, and how to apply that to ensure you have better customer and partner relationships. So, given that all this involves data, I'm very pleased that we're going to hear now from Jeff Morris. He's the VP of Product and Solutions Marketing at Couchbase. Welcome, Jeff. So you would have heard Jean talk about these different sources of data and where they come from, internal, external, and lots of different places. So very, very complex topic. And in order to get the right information in front of the right people at the right time to make the right decision. So looking forward to hearing how to achieve that.
Yeah, absolutely. And I think what's most interesting about this is I can actually help put, characterize the things that Jean is doing, and sort of demonstrate how she's doing it, right? And what things are taking place in the background that gives her that customer profile and the flexibility to modify the customer profile as she's as the customer comes on board, and then making sure that they are credit worthy all the time. Jean happens to be one of our customers as well. So what I want to end up talking about is redesigning our data architectures for better modern application development. So what I'm going to end up doing is we'll talk about first what those requirements are, both for a modern database and a modern application itself. And then we'll get into some of the deeper elements of this. We'll talk a little bit about microservices and the way that developers themselves, they all have their particular penchant, their particular desires for development stack, API usage, and and access methods that they want to get the data in order to feed their applications. And then we'll start to mention some of the other characteristics of a data architecture that will make both everyone on the development team more comfortable, right? And we'll talk about the familiarity of the system. I'll talk a bit about distributed cloud deployments, both from a self-managed standpoint as well as a fully managed hosted solution. And at the end, I'll do my little spiel on Couchbase Capella, but it's only going to last a slide or two. So let's talk about these core requirements, and hopefully as we discuss these, you'll recognize that this is indeed the way that applications are evolving today. Number one, they need to deliver to the end user or the consumer a really great user experience. And even for Jean's application, the notion of having a high quality customer profile for all the information that they're collecting and delivering back to their customers, that's part of the great experience that she's going for. These applications, of course, need to be available anywhere and everywhere. And that includes all the way down to mobile devices and IoT devices. And in many cases, staging data between what might be your core server and then staging data and letting it pass through edge environments and then to devices. So we want everything to be real time, and in many cases operate on active data. And we want to make sure that we're gaining both that familiarity and comfort and trust of dependable transactions inside of the application itself. So that's kind of our user characterization. But then we want to talk a little bit about deploying the deployment characteristics that we're starting to see, or we're certainly seeing in across the install base. We need to support hybrid clouds. We need to support other emerging network technologies like 5G. All of this has to be 100% available and operate at global scale. And of course, this is why I'm speaking in front of everyone in Singapore. You need flexible management options, and ultimately for the developer, what we need is to both cater to their particular desires. You have a development stack you prefer. You have APIs that that you want to be using, and also tap into their core skills. There's a high likelihood that everyone knows SQL, for example, and has a preference for a particular programming language, and we need to make sure that we're supporting those, as well as the emerging best practices of building microservices-based applications, like I'll show you in a minute. So when I really start to characterize what's driving customers to seek new solutions, it really falls into these four categories of topic. Number one, their existing systems, no matter what they happen to be, are starting to fail in terms of performance. They're becoming overloaded, and certainly the pandemic created and illustrated the move of all of your customers and your employees to online work and and dispersed outside of the office really may have stressed a lot of these applications that were running previously. Um, Also, because of that same situation, applications need to improve their flexibility. That sometimes means the schema needs to change dynamically and needs to change on demand without having to ask permission of the database administrator. Also, in many cases, we're finding that these applications need to support mobile environments and support distributed computing capabilities, including those cross-cloud replication kinds of situations. And finally, even if you have moved into the cloud, right, you are constantly looking at driving down your total cost of ownership, and there's means that you can attack for that, so that you're not getting instance overload in the case of running a lot of cloud instances with a lot of databases. So these applications are really starting to look pretty interesting to us. For example, we have a personalized application, Staples, that is giving you your shopping list as you're in store and keeping track of inventory in the background. If you're going on a cruise, Princess Cruise Line uses that medallion to actually keep track of the individual themselves. This young lady is picking her avatar, but it also acts as her room key. And it also acts as her payment device if she wants to buy a souvenir. And it also happens to know location information, so that if mom is in the gym and the kids are at the pool, mom can figure that out using a mobile app and triangulate and know where the kids are. And of course, it creates that really interesting customer experience, in that the kids will always get their preferred breakfast every morning when they go to the dining room. And then, of course, the pandemic also drove a high degree of video and media consumption. So, folks like DirecTV need to make sure that we're keeping track of what programming we've watched and where we left off, and what we might want to watch downstream. But things get really even more interesting when we look at this iSync device, which is actually performing a medical exam, an eye exam, on this individual, but doing so through almost an Oculus-like device there. And lastly, our Northwestern University has got a health monitoring application that runs on smartwatches and is advising you as to what you might want to be eating, what your diet is, looking after diabetic conditions or other health conditions that you may or may not be experiencing. And what's really cool about many of these applications is that the paradigm is shifting from the standpoint of the user invoking the application, which is kind of what we all do today, to actually the application invoking and notifying the user themselves. So the application is operating much more independently, let's say. So these kind of customers operating across the board, we're supporting folks like FICO, who's doing fraud prevention and fraud detection globally across 9,000 banks. They're covering 3 billion accounts. That's pretty large. And they're keeping track of every one of those accounts inside of Couchbase. Carnival and Princess Cruise is the example I gave you a moment ago. But even LinkedIn is keeping track of your information feed and making sure that the delivery of that is very, very fast and very responsive as a caching system, given that they're running at more than 10 million requests per second, and well over 575 million users. That's pretty good. So all of these core requirements are illustrated that I mentioned before in each of these kinds of account situations. So let's talk about how you might go about developing or redesigning your architecture to provide those capabilities, but also save yourself some time. So we'll talk a little bit. First, I want to kind of lay the groundwork, the foundation of using JSON as a data format for you to both store and access data. So it's really handy because it makes changing that dynamic information that you want to keep track of, it makes changing that information really easy and actually something that application developer can do rather than the DBA. So again, this is another paradigm shift where the application and the developer of the application controls the data that the application needs, and not vice versa. So really compelling there. And then you can access JSON data in a number of different ways, whether it's a direct access through your favorite API to the key value store itself, or to the key values in the document. You could use SQL++ as a query language. You can use search. You could do large-scale analytics in this kind of environment as well. So we like that flexibility of JSON here a lot. So now let's kind of apply it. And what I want to illustrate here is, when we're building these microservices-based application, we're trying to make functions that are operating cleanly and independently from one another. And what happens in many cases like this, and this is true whether it's a self-developed and self-managed environment or a fully managed hosted environment, you've moved into AWS or your favorite cloud, you start to recognize that, well, I still need high performance in-memory processing of a cache. And I need that document flexibility of a JSON document. But then I want transactionality. I want query flexibility. I'd rather not have to learn a new query language. I want search functionality. I want streaming and eventing capabilities. I want those large-scale analytics, and it's got to be enterprise secure. Well, what's really, really interesting here is, every one of these requirements could be satisfied by a different technology, right? We run down the line here. We've got Redis, Mongo, Postgres, Oracle, Elastic, Kafka, and Spark. But that's creating a lot of complexity in your environment, and I'll talk about that in a minute. But let's also look at the development stack that you want above this. Right, you want to use and have that optionality is what we characterize it as. You want to use your favorite development stack here, whether it's a JavaScript-based stack, a Java-based stack, running in the AWS environment, running in .NET, etc. Developers should be able to get to choose what tools and environments they're able to operate in, and serving all of these kind of core capabilities is really the challenge. So let's look at those requirements again and kind of what it really, really takes to build one of these systems. Number one is you need high performance, right? It's got to be fast and responsive. And in many cases, it may involve your delivery architecture. So you move the data as close to where it's going to be consumed as possible. But in other cases, it means that you want to make sure that the database itself is as fast as it possibly can be, which in many cases leads towards needing an in-memory processing system. You want it to be really flexible. I talked about JSON there, but I'd also like that multi-model data access, so that if I needed search, or if I needed the analytic capabilities, or if I needed that key value access to the data store itself, I would really prefer if I had that all in one system. Right? That's and make sure that it's the next one is familiar. As I would really like the query language not to be imperative. I want it to be declarative like SQL is. And if it supports SQL syntax, that's even better, because that's what our people end up knowing and is familiar to them. So the learning curve for them drops pretty dramatically. And finally, in that cloud deployment, I want it to be as efficient as possible. So the whole thing has to be affordable. It can't create a sprawl of instances covering a sprawl of databases. That's really kind of the design we're looking to disrupt. So in this memory first multi-model style architecture, I've got my top level different services that are actually all running in memory. So the JSON document capability, the key value capability, automatic backup, an indexing service, all of these core capabilities are things that are running in the data store in memory, and then making sure that it goes to every element of the cluster or every node of the cluster where data is being managed. And even if it's a globally distributed system, like the knowledge of where an application's data happens to be is going to be built into the SDK and in the application itself. So it always has its data location map available to itself. And if it changes, like you rebalance the data, we'll notify those clients that their data location has changed. So let's look at some of these core capabilities and kind of align them to the values or the requirements we talked about a minute ago. One is in-memory performance, getting direct access, sub-millisecond response to access to the key to the data inside a document. Because a JSON document is basically a document full of key values, key value pairs inside of it. So you want it to be really fast, and oftentimes you choose a singular database for that. But then you want that flexibility for the document data store as well. You want potentially the structure and the familiarity of a relational system. If you need to organize the data in a particular way, you'd like it to kind of map up to traditional schema if you could. You want a full-featured capability of being able to add in geographic search or any other types of data access methods, and ultimately be affordable if you're performing real-time analytics or you're doing a number of other types of processing. So those are kind of the core modern database capabilities we want to support. And we can look at another capability on the affordability side is how dense and efficient is the database itself for keeping its data, right? Can it move from how much data is it able to hold on a node, and kind of separate that storage from processing, as we all expect databases to do right now. But what we ultimately really want to see is a more densely packed set of nodes and a better memory utilization against those nodes, so that you get much better performance and economies of scale. And that's what a high density storage engine is going to afford you. So let's wrap it up for a second and look at what the benefits, if you attack that database sprawl problem first, because this is oftentimes, like I said, the architecture that you walked into in your favorite cloud provider, and you started building your old design but in the cloud. So if you had a system that supported a cache and a document store and had ACID transactions and had a familiar SQL query language and had geo search and full text search and had streaming and eventing, plus analytics, plus security, plus mobile synchronization out to however many mobile clients you want, think of the benefits you'd gain, right? You'd have much less data duplication across all these different data stores. You'd have much easier maintenance. You'd actually reduce the complexity of your underlying architecture, which not only makes it more efficient, but easier to maintain, as I mentioned, and probably allows you more time to focus on core features of your application. And you end up accelerating your release cycles. So there's a bunch of really big benefits to this multi-model delivery mechanism for these microservices applications, if you can find a multi-model system to support that. So let's talk very quickly about the query activities and how nice it is to have SQL as the foundation, which is of course declarative. You only tell it how to get what data to get, not how to get it. So you can see that matching up what traditional SQL 92 and a relational SQL looks like versus what SQL++ looks like versus what the Mongo query language looks like. Much more, the Mongo query language is imperative. It tells you how to go get the data. You're going to write a lot more code. It's going to take you a longer time, and it's going to be harder to debug because it's not quite as legible as the traditional SQL capabilities. So, and then I talked about data structures, and really we want to be able to map your relational structures, if you've got a relational based system, into a NoSQL system like this. So you want to have a hierarchical or a multi-layer system here to organize everything. We match buckets to a database. We call the schema that you have, we call that a scope. Your tables are going to look in a NoSQL system as collections. And then, of course, the rows in the table are documents. The key value pairs or the arrays inside the document are, of course, the cells in the row. So you gain a lot of organizational advantages here, so that governance can be easier, replication can be more localized and more specific. A lot of big tenants can be, multi-tenancy can be supported through here. So a lot of big benefits there. So let's talk a little bit about just two deployment options. The first one is manage it yourself using cloud native database automation. So deploy your system in containers, to help make your DevOps people operate more efficiently, support your CI/CD kinds of delivery models, like I just mentioned, for serving your microservices apps, and give you a much easier way to manage, grow, deploy, upgrade your system. So for self-managed systems, we've really embraced the Cloud Native Computing Foundation's set of a whole ecosystem, which is fundamentally operates around Kubernetes, but then has added a number of additional capabilities, whether it's Helm charts for your deployment framework, a lot of monitoring and logging capabilities through Prometheus or Fluentd, and then operating in many of the commercialized Kubernetes environments like OpenShift or GKE, EKS, and Amazon, as you like. So you can really see that it would be very easy to deploy this modern architecture in your favorite cloud. And of course, the next thing is, all right, so it needs to support that processing anywhere. So you want to have really good cross data center replication with filtering, not only for high availability, but also for data localization and or data sovereignty, and make sure that it also gets all the way out to your mobile devices and then further to the edge. And lastly, I want to talk very quickly about Couchbase Capella, which happens to be the hosted database as a service, which supports all these core capabilities. It's got the memory first design, so it's fast. It's flexible because of it. It's got both the multi-model services I mentioned and that JSON foundation. It's familiar. It uses a query language that you're used to already, has schema, has ACID transactions, has user-defined functions, and supports over a dozen SDKs. So you get your choice of programming language. It's affordable as it deploys in the cloud, and really sets yourself up for a future-proof kind of environment. So like I said, really simple to get going. You can develop all your different use cases within it, and it's super fast. This is as easy as it gets to sign up. You can be up and running in about 2.5 minutes, or we can walk through a full proof of concept for that matter. And so finally, when you look at how this compares to other systems, the way we tend to structure this is how flexible are things, how available is that structure on demand? Am I using a declarative language versus an imperative one? Has it got the transactionality? Has it got the low latency and speed? Does it scale everywhere, et cetera? And whether you're deploying relational capabilities or typical document capabilities, there's a number of different areas where there's big advantages here. So technically, right, your skills and resources are utilized optimally. It imposes no learning curve on you. Your developers can gain efficiencies from really advanced capabilities like advice as to what index to build or use if it's already in there. And then support your CI/CD processes so you can rapidly deliver and modify your application as you go. In fact, I have a customer who's got about 200 microservices built. They roll out every single day. He says that the CIO says, I wake up every day and I don't know what I'm going to build, but I don't really care. I know by the end of the day, we'll have something rolled out. And even if it's a little buggy, it's okay, we'll fix it tomorrow. So they're supporting those really rapid cycles. And because it supports this distributed asynchronous clustering, it's not only fast, but it gets the data out to where it's supposed to be consumed and processed. And then finally, for your business, right, you get that faster development cycle. Your customer satisfaction goes up because you've got more and better features in your app. You get exceptional reliability out of a less complex system, and you get better personalization all the way around because of that JSON foundation. You don't get locked into a cloud vendor. You get a really predictable operational model, and gain significant savings in database as well as infrastructure costs by consolidating these things. So that's ultimately
so Jeff, I think the key point I took out of this is,
yep,
you've got, with so many data sources, such a diversity of data sources, that there really isn't a scalable, sustainable way of using all of those, unless it's a microservices architecture. If you try
Right.
to do it with a monolith, it's
Yeah.
going to be very brittle. The moment you're going to have too many hands on the one thing, and the moment you change something, something is going to break somewhere.
Yeah.
So
Very
the
much so.
microservices is the only way that you can make sense of such a diversity of different data sources that you need to apply. But that also does create a challenge in that you mentioned data sprawl. Well, there's innovation happens before standards do, and
Mhm.
for an organization that has already started innovating with different things, you mentioned some of the things that you can achieve to draw things together. But what do you do? I always like to ask the question: what do we do Monday? What if you're faced with you've got maybe a monolith, and maybe you've done some things in a cloud with a couple of different technologies, SQL, NoSQL. What's the first? What's the approach you need to take to
Well,
start
yeah,
to bring
the
that?
approach to start that we often go after is, one, find the least intrusive capability that you can introduce that solves one of those early pain points I mentioned. So it could be performance, it could be flexibility, it could be mobility or cost, right? And in any one of those pain points, like the performance one, introducing a caching service in front of an ailing application is not very invasive to the application nor the data system,
Mm,
but it proves out the model. Or offering up flexibility because you want to expand the user profile or the account profile of something, like, remember, Jeff likes blue,
mm,
and log that from the application. You've just created a new data element without having to go through a database release cycle. Those
mm,
kind of things are, introduce those non-intrusive capabilities, and then let it more organically kind of grow into getting rid of some of these other ones, right?
mm,
Search might not need something as elaborate as Elastic, right? The data streaming might not need something as full capability as Kafka, right? You may just have 2 channels worth of data going along.
mm.
So you can also start to gain benefit there of both eliminating redundant technology, stop paying for it, stop needing to maintain it, and still have the full featured kind of capabilities going into your application.
Oh, great. Well, thanks for sharing that, Jeff. It's a great way to cap off this track, actually, because we started by learning about the why, and you've stepped into the how.
Approaches
So
for the how. Yeah, that's good.
thanks very much.
Thanks so much, John. That's been a great event.